If I have to read one more headline about a celebrity shrinking into oblivion, or see one more before and after photo on Instagram, I might actually scream.
Yeah, yeah.
We are just drowning in this discourse about weight loss drugs. Semaglutide, GLP-1s, it feels like the entire cultural conversation right now is just obsessing over waistlines.
It's definitely the zeitgeist moment. You can't escape it. It's at the dinner table. It's in the boardroom. It's everywhere.
Exactly. And frankly, it's getting a little boring. But, and I love a good but, I was digging through the stock of research you sent over this week, and I had a bit of a realization.
Oh, yeah.
What if the weight loss is actually the least interesting thing these drugs do?
I would say that is not just a what if.
Hmm.
That is exactly where the science is heading. If you look past the vanity metrics, we are seeing the beginnings of a completely different story.
Because the papers we have today, this isn't about fitting into skinny jeans. We're looking at a stack that suggests we are on the cusp of a whole new era of preventive medicine. We're talking about drugs that might actually be the longevity holy grail we've been promised for decades.
That's the mission for this deep dive. We're going to look under the hood. We aren't talking about calories. We're talking about rewiring the brain's fundamental circuitry.
Okay.
We're talking about cleaning the blood to reverse cognitive decline. And we're going to end with a study on a drug cocktail that reversed aging in mice, but with a massive, massive catch.
A catch that might actually change how we think about gender in medicine forever.
It really might.
But let's not get ahead of ourselves.
Let's start with the GLP-1s.
Okay, so everyone knows the standard line. You take the shot, your stomach empties slower, you feel full physically, so you stop eating.
Right.
It's plumbing.
That's the plumbing explanation, yes. And it's true. But it's incomplete. We have a paper here from Science that suggests the real action isn't in your gut at all.
Where is it?
It's in your head, specifically in a tiny region called the dorsomedial hypothalamus, or DMH.
The DMH. And this study introduces a term that broke my brain a little bit. Pre-ingestive satiation.
Right.
Just looking at those words. Pre-ingestive. That sounds like a paradox. How can you be satisfied before you've actually ingested anything?
It does sound like a magic trick, doesn't it? But think about it from an evolutionary standpoint.
Okay.
If you had to wait for food to physically hit your stomach and be digested before your brain knew to stop looking for food, you'd explode. You'd overeat constantly.
Okay, that's fair. So there has to be a signal that says incoming.
Exactly. But this study shows that GLP-1s dramatically amplify that signal. In the clinical trials, patients reported feeling full just by looking at food cues.
Just by looking at them.
Yeah, they see the menu or they smell the food, and the brain just says, nope, we're done.
Wait, so let's ground this. I'm at a restaurant. I'm starving. I see a burger on the next table. Normally, my brain screams, get that. You're saying on these drugs, I see the burger and my brain says, I'm stuffed, before the waiter even brings me a water.
That is essentially what is happening. The researchers identified specific neurons in the DMH that express GLP-1 receptors.
Okay.
And they found two types, pre-ingestion neurons and ingestion neuron.
Pre-ingestion neurons. So these are the anticipatory guys.
Right. These neurons light up when you are just seeking food or looking at it. They act as an anticipatory brake.
The brake, yeah.
They project to the hunger centers of the brain, the AGRP neurons, and they shut them down.
I need an analogy here because AGRP neurons sounds like a sci-fi villain.
Okay, think of the AGRP neurons. The hunger neurons like a gas pedal that is floored. Your foot is stomped down on it.
Always.
Normally, you have to eat a massive meal to physically lift your foot off that gas. What GLP-1s do is they cut the fuel line to the engine the moment you even see the gas station.
That is wild. So it's hacking the reward system.
It is.
It's not about a full stomach. It's about a quiet brain.
Precisely.
Yeah.
And that explains why people talk about the food noise disappearing.
Yeah.
It's not willpower. It's that the neural circuit that screams hunt and gather is being dampened before you even pick up a fork.
But if these receptors are in the hypothalamus, which is deep in the brain, where else are they? Because if I'm injecting something that rewires my fundamental survival drive, I kind of want to know what else it's rewiring.
That is the trillion-dollar question. And this brings us to the second part of our stack, a systematic review that looks at GLP-1s as neuroprotective agents.
Neuroprotective, so protecting the brain from damage.
Yes, the review highlights that these receptors are everywhere, not just in the appetite centers. And when you activate them, you do two very important things.
Okay.
You reduce neuroinflammation and you stop apoptosis.
Apoptosis is cell death, right?
Correct. So you are cooling down the brain lowering the inflammation that tends to ramp up as we age, and you are literally telling neurons, do not die today.
Okay, I have to play skeptic here for a second. We have heard this song and dance before. Every few years, there's a miracle drug for Alzheimer's. Then they get to phase 3 trials and they fail miserably, usually because they target those amyloid plaques we always hear about.
Right. The plaques.
Why should we believe this is any different?
That is a very valid skepticism.
Yeah.
The graveyard of Alzheimer's drugs is vast.
Right.
But here's the difference. Most of those failed drugs targeted the plaques, the trash that accumulates.
Right.
But many researchers now think the plaques are a symptom or a gravestone, not the cause. The cause might be metabolic.
Metabolic, like brain diabetes.
Exactly. In fact, some people call Alzheimer's type 3 diabetes. The brain becomes insulin resistant, it can't get energy, it gets inflamed, and it starves. GLP-1s fix that metabolic dysfunction. They improve the brain's ability to use energy and lower that chronic fire of inflammation.
So instead of trying to sweep up the trash after the house is burned down, we are installing a sprinkler system to stop the fire in the first place.
That is a beautiful analogy. And because of this mechanism, we have the EVOKE and EVOKE Plus trials happening right now. These are massive phase 3 trials testing semaglutide specifically for early-stage Alzheimer's.
If that works, I mean, forget the skinny jeans. If that works, this becomes a drug you take to keep your personality.
It changes the classification entirely. We stop calling them weight loss drugs and start calling them longevity therapeutics.
Right.
The Nature editorial we have argues exactly this. A true longevity drug isn't just one that fixes one thing. It targets the underlying processes of aging to prevent multiple diseases.
Right, because usually you take a statin for your heart, a different pill for your kidneys, something else for your liver.
Exactly. But GLP-1s are showing benefits in heart failure, kidney disease, liver disease, and now potentially neurodegenerative disease.
Yeah.
It's a systemic reset.
It's moving from whack-a-mole medicine to treating the whole system.
Correct.
Speaking of treating the system, let's pivot. GLP-1s are about putting a molecule into the body to trigger a response. But the next source in our stack takes the exact opposite approach. It's about taking the bad stuff out.
We are talking about therapeutic plasma exchange, or TPE.
Okay, I have to address the elephant in the room. When I hear plasma exchange and anti-aging, my brain immediately goes to that Silicon Valley trope. You know, the tech billionaire with a blood boy.
The vampire myths?
Yes. The idea of harvesting young blood to stay young forever. Is this that? Because if it is, I'm out.
I am happy to report it is not that. That is the Hollywood version. TPE is a legitimate, established medical procedure, often used for autoimmune diseases.
Okay.
The concept isn't about adding young magic in. It's about taking old toxic out.
Okay, so walk me through it. I go to a clinic. What happens?
They hook you up to a machine that separates your plasma, the liquid yellow part of your blood, from your red and white blood cells.
Got it.
They discard your plasma and replace it with fresh medical-grade albumin, a protein fluid.
So it's literally an oil change. You drain the dirty oil, keep the engine parts, the cells, and put in fresh oil.
It is the most accurate analogy we have. You are removing the dirty oil, which is full of inflammatory proteins, autoimmune antibodies, and circulation toxins.
But is this just theoretical? Or do we have hard numbers? Because cleaning the blood sounds nice, but does it actually do anything for a human brain?
We have numbers. The AMBR study Alzheimer's management by albumin replacement.
AMBR.
Yes, this was a rigorous randomized clinical trial.
Okay, hit me with the stats.
They treated patients with mild to moderate Alzheimer's. The group that got the plasma exchange showed a 66% reduction in cognitive decline.
Whoa, 66%.
Yes, and a 52% preservation of daily function. That means the difference between being able to dress yourself and feed yourself versus needing full-time care.
That is significantly better than almost any drug we've seen approved recently.
It is. And the theory is molecular cleansing. You are washing out the beta amyloid floating in the blood, which creates a concentration gradient.
Okay.
Essentially, you pull the toxins out of the brain and into the blood, then wash them away.
Like changing the water in a dirty fish tank so the fish can finally breathe.
Exactly.
But, and here's the practical question, is this actually accessible? This sounds like a procedure that requires a hospital, a machine, a lot of money.
It does.
Are we looking at a future where the rich get clean blood and live to 110 and the rest of us are stuck with our dirty oil?
That is the hurdle. Right now, this is expensive and time-consuming. It's not a pill you take at home. It's a procedure.
Right.
However, knowing the mechanism works is the first step. If we know what in the blood is causing the aging, we might be able to develop filtration devices or simpler ways to achieve the same result.
So the science is solid, but the delivery mechanism is still in the beta testing for billionaires phase.
For now, yes. But the MBR study proves the concept. The environment your cells live in matters as much as the cells themselves.
Okay, so we've hacked the brain with GLP-1s, we've cleaned the blood with TPE. But this last study, this is the one that really made me sit up straight. Because this wasn't about preventing decline, this was about reversal.
This is the most radical paper in the stack. It's a brand new study on a drug cocktail involving oxytocin and an ALK5 inhibitor.
And just to set the stage, we aren't talking about healthy middle-aged mice here.
No, they used mice that were 25 months old. In human terms, that is a 75-year-old. And specifically, they were frail.
Okay.
These were mice that were essentially in the nursing home.
Just the goal was to see if they could bring them back.
The researchers took a brilliant approach. They said aging isn't one thing. So they looked for two things that move in opposite directions.
Right.
First, oxytocin. We know it as the love hormone, but it's actually a crucial carpenter for tissue repair. And it drops as we age.
Okay, so the carpenter quits. That's problem one.
Problem two is TGF-beta. This is a signaling pathway that increases as we age. When it gets too high, it causes fibrosis scarring. It blocks regeneration.
I liked the analogy you used in our pre-show chat. If oxytocin is the carpenter, TGF-beta is.
TGF-beta is the guy who shows up and just dumps concrete everywhere. He's trying to patch holes, but he's making a mess. So as you get old, you have no carpenter, and the concrete guy is going crazy. Your organs get stiff and scarred.
So the cocktail is hire back the carpenter, oxytocin, and fire the concrete guy, ALK5 inhibitor.
Exactly. They injected this cocktail into these 75-year-old frail mice.
And the results were, well, shocking feels like an understatement.
The male mice lived 73% longer from the start of treatment compared to the controls.
73%. I want to wrap my head around that. If I'm a 75-year-old human and I start this treatment,
it would be roughly equivalent to living to be, say, 100 or 110, while your peers passed away at 80.
And were they just lingering? Because living to 110 isn't great if you're bedridden.
That's the health span versus lifespan distinction. They weren't just alive, they were robust. They had better grip strength, better endurance on treadmills. Improved memory, they were functionally younger. The study said it youthfully normalized their blood proteins.
So they essentially turned back the clock.
Yes.
But you kept saying male mice, and I know in science details matter. What happened to the females?
This is the twist that has everyone talking. And it's a controversial one. This massive 73% life extension.
Yeah.
It basically didn't happen to the females.
Zero.
They saw some short-term changes in protein markers, and it did improve fertility in middle-aged females, so it did something, but it did not extend their lifespan or reverse frailty the way it did for the males.
That is a massive discrepancy. 73% versus basically nothing. Why?
This highlights a huge blind spot in medical history. For decades, scientific research, especially in mice, was done almost exclusively on males.
Right.
The assumption was that females were too complicated because of estrous cycles and hormones.
The male default.
Exactly. So we built entire models of aging based on male biology. This study suggests that the mechanism of aging, the actual levers that break down the body, might be fundamentally distinct between sexes.
So the carpenter and concrete problem might be a male problem?
It might be. Females might age through a completely different pathway.
That is terrifying, but also enlightening. It means we can't just have a pill for aging.
No. It implies that the future of longevity medicine is going to be radically gender-specific. What works for your husband might do absolutely nothing for you, and vice versa.
I mean, think about the societal implications of that. If we crack the code for men 10 years before we crack it for women, or the other way around, we are looking at a demographic imbalance that is hard to even imagine.
It's the his and hers future of medicine.
Yeah.
And it means we need to double down on female-specific aging research immediately, or we risk leaving half the population behind.
It really connects all these dots, doesn't it? Whether it's GLP-1s, rewiring the hypothalamus, TPE cleaning the plasma, or this hormone cocktail, we are moving away from sick care.
We are. We are graduating to system maintenance. We aren't waiting for the engine to blow up anymore. We're tuning the anticipation circuits, changing the oil, and firing the incompetent concrete guys.
It's incredibly exciting, but also a lot to process.
It is, but it's better than the alternative.
True. I want to leave the listener with that thought about the gender split. If the biology of aging is that distinct, Are we prepared for a world where medical breakthroughs are that selective?
It's a profound question. We might be heading toward a future where equality in medicine requires completely different treatments to achieve the same result.
Something to chew on, preferably before your hypothalamus tells you you're full. Thank you for guiding us through this stack.
My pleasure.
And thank you for listening to this deep dive. Stay curious, stay skeptical, and we'll catch you on the next one.